In the heart of many industries, from power generation to manufacturing, massive boilers work tirelessly, converting fuel or biomass into energy. But with every burn, there's a challenge: soot. It originates primarily due to incomplete combustion of fuel or biomass in boilers. This buildup reduces heat transfer efficiency, increases fuel consumption, and raises the risk of overheating and tube failures, highlighting the importance of effective soot cleaning systems. The traditional solution? Soot blowers. Soot blowers have been the go-to method for decades. Using high-pressure steam, these devices aim to dislodge the buildup and keep systems running smoothly. The global market for soot cleaning equipment is experiencing significant growth, driven by increasing demand for efficient boiler cleaning solutions across various industries. While effective to an extent, traditional soot blowers come with significant drawbacks. First, they're imprecise. Soot blowers clean in fixed patterns, often missing stubborn deposits or over-cleaning areas, causing unnecessary wear and tear on tubes. Second, they consume enormous amounts of energy. This inefficiency drives up operational costs. Third, they require constant maintenance. The complex mechanisms of soot blowers are prone to frequent failures due to the high temperatures and the strain of handling pressurized steam, leading to significant wear and tear on parts. The result? Reduced efficiency, higher maintenance costs, and increased emissions. In addition to traditional soot blowers, some facilities have adopted other cleaning methods like gas explosion technologies. Gas explosion cleaning methods use controlled gas explosions to generate shock waves. These shock waves travel through the boiler, dislodging soot and deposits from tube surfaces. Gas explosions create very high-pressure pulses, but with very low gas volumes. Due to low gas volumes, the resulted pressure waves deliver limited energy, and they come with their own set of challenges. Firstly, these systems are complex. The intricate mechanisms involved in generating controlled explosions require precise engineering and integration into existing boiler systems. Secondly, the initial investment is substantial. The advanced technology and specialized equipment lead to higher upfront costs compared to traditional methods. Additionally, maintenance can be demanding. The sophisticated nature of these systems necessitates regular upkeep by trained personnel, potentially increasing operational expenses. Moreover, safety concerns arise due to the use of combustible gases. Strict safety protocols must be in place to prevent accidents, adding another layer of complexity. But the evolution of cleaning technology doesn't stop there. Airmace technology has entered the market, offering a revolutionary approach to boiler cleaning. Airmace is low-cost, extremely effective, and highly flexible. It can be adapted to various boiler sizes and pressure ranges, requiring only water and compressed air for operation. What sets Airmace apart? Its simplicity and durability. With no complex mechanisms, it minimizes maintenance demands and reduces the risk of mechanical failures. Airmace is also environmentally friendly. By eliminating the need for steam, it drastically lowers resource consumption and reduces operational costs. Its precision cleaning ensures thorough soot removal, enhancing thermal efficiency and prolonging equipment lifespan. And with its adaptability, it's the perfect solution for any type of boilers.